Hello everyone, this is our Group 8 and 9 reporting for Physical Science, and today's lesson is all about limiting reactants and the amount of products formed. In this lesson, it's better we prepare periodic table of elements, pen and paper, and also a calculator so we are able to compute. To know how to calculate limiting reactants in the amount of products formed, we have to use stoichiometry. So what is stoichiometry? Stoichiometry is a section of chemistry that involves using mole and mass relationships between reactants and or products in a chemical reaction to determine desired quantitative data. Ang mga ratios ng mga ito ay nakabase sa stoichiometric coefficients, kaya dapat ang reactions na gagamitin natin must be balanced. Let's start on finding limiting reagent. So what is limiting reagent? Limiting reagent is the reagent that is completely used up in the chemical reactions. For example, what is the limiting reagent if we start with 2.80 grams of aluminum and 4.25 grams of chlorine? Here is the equation. Let's check it first if the reaction is balanced. If it's balanced, then we should proceed. First step is to convert first the amounts in grams to moles. Then you just write it down. Moles of aluminum is equal to the given 2.80 grams of aluminum. Multiply this to molar mass of aluminum. The molar mass of the element is simply the atomic mass in the grams per mole. You can simply get that from the periodic table of elements. The moles of aluminum is equal to 1.104 per moles of aluminum. So, in the second naman ay yung grams of chlorine. Let's convert it into moles, which is equal to 4.25 grams of chlorine, and then multiply this to the molar mass of chlorine. Tignan natin ang atomic mass sa periodic table of elements times 2 dahil may 2 atoms of chlorine. So, equal to 70.90 grams per mole. So, this means for every mole of chlorine gas, meron tayong 70.90 grams. So, we just write the molar mass and multiply it, and you will automatically get the answer, which is equal to 0.0599 moles of chlorine gas, or 5.99 times 10⁻²⁰ moles of chlorine gas. And let's get back to our previous session or discussion where we're able to get the molar mass, and it's calculated by multiplying its relative atomic mass by the molar mass constant equal to 1 gram per mole. The molar mass constant can be used to convert mass to moles. By multiplying a given mass by the molar mass, the amount of moles of the substance can be calculated. After natin ma-convert ang mga given mass and moles, pwede na tayong magsimula na mag-compute. So, this is the moles of aluminum and moles of chlorine gas. The method 1 we use is to compute the actual ratio which a moles of aluminum of our chlorine gas is equal to 0.104 mole of aluminum over 0.0599 mole of chlorine gas. Our answer is 1.74 mole of aluminum over 1 mole of chlorine gas. The stoichiometric ratio 2 came from balanced chemical equation. So there are 2 moles of aluminum divided by 1 mole of chlorine gas. Our answer is 0.67 mole of aluminum over 1 mole of chlorine gas. So let's compare our answer. We got an actual ratio of 1.74 and stoichiometric ratio we have 0.67 mole of aluminum. So we notice here that our actual ratio is greater than our stoichiometric ratio. What does it mean? It means meron tayong maraming aluminum na pwede mag-react sa bawat mole ng chlorine gas. Therefore, ang excess reagent is aluminum and the limiting reagent naman is chlorine gas. In method 2 naman, we can choose any of the reactants. In our example, we can choose an aluminum or chlorine gas. Remember, whatever we chose, we always pretended it is the limiting reagents And then, let's calculate the moles of our pretending limiting reagent. So, in our example, kunwari, our aluminum is limiting reagent and will calculate the required amount of chlorine gas. So, nandito na ang computation. So, computation natin, ang kailangan natin ay Cl2 is equal 0.156 of mole Cl2 kung aluminum ang ating limiting reagents. Pero sa example natin, ang number moles of Cl2 is 0.599 moles lang, which is less than 0.156. Yung na-compute natin, which means mauubos ang chlorine bago pa mag-fully react sa aluminum. That's why the limiting reagent is the chlorine or Cl2.
Let's use the balanced chemical equation for method 3. 1 mole of reaction is the number of moles given by the coefficient in our balanced equation react. 1 mole of reaction is when 2 mole of aluminum react. When 3 moles of chlorine gas to produce 2 moles of aluminum chlorine. Gamitin natin yan to set up ratios. Our answer of the first mole in aluminum is equal to 0.052 mole reaction, and for second is 0.599 moles of chlorine. Ang sagot natin ay 0.052 mole reaction. Now, the question is, which has less number of moles? So, let's just compare. And the answer is chlorine gas, and so, this is limiting reactants or limiting reagent. If we already know which is limiting reagent, and then we are able now to compute the theoretical yield. So what is theoretical yield? And how to calculate the percent yield of a reaction based on the theoretical and actual yield. By the way, for this topic, Ms. Cheryl Pabilona will discuss this for us.
Example 2, calculating theoretical yield. Now that we know the limiting reagent, we can use the information to answer the following question. What is the theoretical yield of aluminum and chlorine gas 3 that the reaction can produce when we are start with 4.25 G of chlorine gas, our limiting reagent? We can use the moles of limiting reagent plus the stoichiometric ratios from our balanced reaction to calculate the theoretical yield. The coefficients from the theoretical yield in moles equal 5.99 times 10 below minus 12 and mole chlorine gas 2x times 2 moles aluminum gas 3 and below 3 moles chlorine gas 2x and equals 3.99 x 10 up minus 2 in mole aluminum gas 3. Balance reaction tells us that every 3 mole of chlorine 2 we should make 2 mole of aluminum and chlorine gas 3. Therefore, the theoretical yields in moles is the theoretical yield is usually expected to have units of mass, so we can convert moles of aluminum and chlorine gas 3 to grams using the molecular weight. Theoretical yield in grams is equal 3.99 times 10 minus 2 above, and molecule and mole in aluminum gas and molecule gas is 133.33 G aluminum in chlorine gas, and below is 1 mole aluminum in chlorine gas 3 x and equals 5.32 G aluminum in chlorine gas 3. Percent yield. The theoretical yield is the maximum amount of the product you would expect from a reaction based on the amount of limiting reagent. In practice, however, chemists don't always obtain the maximum yield for many reasons. When running a reaction in the lab, loss of product often occurs during purification or oscillation steps. You might even decide it is worth losing 10% of your product during an extra purification step because it is more important to have extremely pure product as opposed to having a larger amount of less pure product. Since chemists know that the actual yield might be less than theoretical yield, we report the actual yield using a percent yield, which tells us what percentage of the theoretical yield we obtained. This ratio can be very valuable to other people who, since percent yield is a percentage, you would normally expect to have a percent yield between 0 and 100. If your percent yield is greater than 100, that probably means you calculated or measured something incorrectly. Example 3. Calculating theoretically and percent yield. For example, the decomposition of magnesium carbonate MgCO3 forms out 15 grams of magnesium oxide. In experiment, the theoretical yield is known to be 19 grams. What is the percent yield of magnesium? Well, magnesium and chlorine gas. What is the percent yield of the reaction? First, we check to see if the reaction is balanced. It looks like we have equal numbers of all atoms on both sides. So now we can move on to calculating the theoretical yields. The calculation is simple. If you know the actual theoretical yields, all you need is substitute the values into formula. Percent yields equals 15 grams and 19 grams x 100, it's 100%, and percent yields 79%. Usually, you have calculated the theoretical yields based on balance equations. In this equation, the reactants and the product have a 1 mole ratio. So if you know the amount of reactants, you know the theoretical yield is the same value in moles, not grams. You take the number of grams of reactant you have converted to moles and then use this number of moles to find out how many grams of product to expect.